Okay, now what's a wave equation? Well, wave equation has to do with the following case. Suppose you have a violin or any kind of string instrument, okay? So if you have a stringed instrument, then if you pluck a string, if you pull this like that and you release it, what happens? It vibrates and you get sounds, right? Okay. And wave equation has to do with modeling this. And again, it can be done in a more precise way, but today I just want to give you some intuitive ideas of what's happening. Okay? So think about this. If the string is bent like this, what's going on in this direction? What's being felt? It's the tension. Tension is, what kind of physical quantity is tension? It's a force, right? Okay, now, if you say uxt is the displacement of the string at position x and time t, okay, so that just think about this as a graph, okay? So at a fixed time t equals to a, you have such a string shape, okay? In that case, depending on how much this is bent, the tension will be proportional to what? How do you express how much a function is bent? What's that?
Curve. Slope.
No, it's not the slope. How is it bent? Concavity, exactly. So concavity has to do with second derivative. Okay. Concavity has to do with second derivative, okay? So concavity has to do with second derivative, and because this is in the spatial direction, this is x, right? That's y or u. So you have to differentiate twice in the x direction. That's the concavity, and your tension is proportional to that. Now, what does F equal to ma say? If you have a force, what does it determine? Mass times a is acceleration. Okay, acceleration is what? Second derivative of the position or the displacement. Second derivative of the displacement. So what you want to do is you want to say that u differentiated twice, which is acceleration, times mass should be proportional to uxx, right? Now, you can't say mass here because it's an entire thing. So you should really replace this by a linear density, right? Usually written as mu or lambda. And then because this is assumed to be a constant, you can just divide this out and say this is proportional to that. And therefore, what is the final thing? You have utt proportional to uxx, so you just have to multiply by constant, right? But instead of using k, you usually put c squared here because that has to do with the solutions. When you write down the solutions, it's easier if you have c squared rather than just the k. If you have k, you end up using square root of k at some point, and it's dirty. So to make things life easier, you put c squared here. So that's called the wave equation.